Okay, I'm going to work through each of the problems on the review. To help you if you need some explanation, I'm going to split this into 2 videos. If you're good with first page, you can jump into the video to go to the second page or whatever part you need some help with. Again, this first page is the format of the test, so we can do all our work here on the left, and then our final answer just needs to be on the right. Number 1 says, given the equation y is equal to 3 times the absolute value x minus 4, subtract 1, we're going to first graph the function. So remember the movements on the graph. Just a reminder, the parent function generally sits at the origin and has a slope of 1. Its equation looks like y is equal to the absolute value of x. Any change from that we call the transformation. So notice in our equation to the left, there's a change here, there's a change here, and there's a change here. So 3 transformations. Adding a number onto the end, right, moved it up or down. This one's negative, so we're going to go down 1. On the inside, it goes opposite direction, left and right, so that's going to go right 4. And then out front, this changes our slope, and because it's greater than 1, we're going to call it a vertical stretch. So off to the right, I'm going to move my vertex from the origin, where it normally would be, down 1 and to the right 4. And then again, it's opening up because there's no negative out front of our equation. So we're going to go up 3 over 1 to create that slope that's stretched by 3. And then we just create our v as best we can. Part B says state the domain. Remember, domain is x values for which the function exists. Any x value works in this function. You can plug it in and you get a real value out. The range, remember the range is where does the function exist in relation to our y-axis. So notice the graph starts here and it goes up forever. So the graph never comes down here. So we would say that the y values are always -1 or greater. So we can write that 2 ways, -1 to infinity, where we include the -1 value. Or again, if you like to use the inequality, y is always greater than or equal to -1. Okay. D asks for the vertex. Remember, the vertex is the point at which the v is created, so that dot right there at the bottom of our v. In this case, the vertex is at 4, -1. It's just a point on the graph. Lastly, describe the transformation. So in comparison to this parent function, how has this been transformed? We could say that it shifted or translated right 4. It went down 1. And stretched vertically by 3. Remember that you do need to be specific enough that I could build the function based off of your description of those transformations. Okay, absolute value. Number 2, this one is solving. It says identify the solution for the equation. This one is a multiple choice question, so I am going to go ahead and solve. Again, we can do all our work off to the left, and then just our final answer needs to get in the answer box on the right. So we start by perhaps distributing the -5. We'll get -35n when we multiply that plus 25. And on the right side of the equation, we have -29, subtract 8n. And then we want to isolate the variable, so put all the variable on one side. Again, if I want to move that across, I have to add 8n, and we do that to both sides of the equation to keep it balanced. And then if I want to maybe move the 25 to the left, or sorry, from the left side to the right side, we're going to subtract it over. So we put those together, and on this left side it looks like we get -27n is equal to -54. We continue to solve by dividing by -27, and -54 divided by -27 would give us a +2. So keeping track of those positives, so it looks like our answer on the left would be n is equal to 2, which is B. Number 3, state the sets of the number system that -7 is a part of. Remember, the number system starts with those natural numbers on the inside, and natural numbers are just counting numbers starting at 1, 2, 3, so -7 wouldn't be in there. The whole numbers include 0, but it wouldn't be in there either. Not until we get to the integers do we start having negative numbers. So integers and then all the number sets moving out. So number or integers, right, then includes rationals. So we include rational. We won't include irrational because it doesn't overlap, but we will include real numbers. So we would include the real numbers as the next set out. And we wouldn't include imaginary because it's here Again, not overlapping, but we would include the next set out, which is the complex numbers. So again, if I start with integers, integers is inside the rational, which is inside the real, which is inside the complex. Okay. Classify the following polynomial by its degree and number of terms. So first of all, we look at this guy. He's got 3 terms. We know it's going to be a trinomial, so it can't be B or C with our multiple choice. And it has a degree of 2, the highest exponent, which means that this is a quadratic trinomial instead of linear, so we're going to choose A. Number 5, evaluate the function h of x is equal to, and then we've got a piecewise function here. Remember that when you're evaluating a piecewise function, the value which you're given only fits into one part of the domain. So if I am given the value of positive 3, I look up here at my domain restrictions, and positive 3 is not less than or equal to negative 4. Positive 3 is greater than negative 4, so I'm going to use this bottom piece because that's where 3 fits in the domain. So we do negative 3 plus 12, which gives us a positive 9. So if I wanted to define h of 3, that's equal to positive 9. Jumping over to the second page, we've got more graphing of absolute value functions. I'm going to walk through these. Again, comparing them to that parent function that sits at the origin and has a slope of 1. So its parent function is absolute value of x. Any change to that is a transformation. Notice here we are moving the graph up 4, and out front it's being stretched by 2. So we're going to go up 4 on our graph, and we're going to put our vertex there. From there we have a slope of 2, so I'm going to go up 2 over 1 to create my v, right? Absolute value functions always create a v. From there, we're going to identify the domain. Remember, the domain is all real numbers. Every x value can be plugged into that equation and output a y value that's a real number. The range, again, if we look at our y-axis like we did on number 1, the graph never comes down here. It doesn't start until actually y is 4. So it goes from 4, including 4, so we use a bracket, up forever. So we use the symbol infinity, or if you want to say y is always greater than or equal to 4, that also works. Again, that vertex is that point where it's making a v, so if I were to define that point on the graph, that's 0, 4. And transformations, this one's been shifted or translated up 4, and it has been stretched vertically by 2. On the right, again, looking at these transformations to start out with, it looks like we're going to go up 3. Again, we're going to go to the right 4. And then notice this guy right here is on the inside, so instead of a vertical, this is a horizontal change. And remember, the horizontal changes by its reciprocal, so this is actually going to be a shrink of 1/4. So we talked about there's 2 ways you can do this, and I'll do kind of the first way and then we'll come back to the other one. Or this negative out front, don't forget that guy, he's going to reflect over the x-axis. So I know that it's going to open down my v. So I'm going to start at the origin, and I'm going to start here by going up 3. I'm going to go up 3, I'm going to go to the right 4. So I know that my vertex is going to be here, except then there's a horizontal shrink of 1/4. So a fourth of 4 would take me back to where my vertex is at 1. Once I'm there, again, this is upside down with a slope of 1, or sorry, a slope of 4 because of our 4 in front of the x, so we go down 4 to the left 1. So this guy is getting really tall and skinny. On your graph, just be aware that if you want to check this algebraically, I'm going to rewrite the equation off to the left. 4x minus 4 plus 3. We can factor out this 4 on the inside of our absolute value bars from the x term just to get an x, and then 4 divided by 4, or sorry, negative 4 divided by 4 would be negative 1. So if we want to check that way, we can check that our vertex matches. It should be at 1, 3 based off of that h and that k. So it looks like our graph is correct. You can also plug that into your calculator to check your graph. Domain, again, all domain values work for this. Range, however, is coming from the bottom. So notice you're going forever in this direction. Because we write intervals from least to greatest, we're going to start at negative infinity, and we're going to include every y value up until 3. So our interval is going to look like negative infinity up to 3, and we'll include 3. Or if you want to say y is always less than or equal to 3, that also works. The vertex, that point that we talked about where it makes the v, is over 1 but up 3, so it's at 1, 3. And the transformations, again, this is upside down, so it's reflected over the x-axis, or vertex, however you want to say that. And then it's shifted or translated up 3, right 4, and then it's shrunk horizontally by 1/4. Absolute value functions. We love them. Okay, on to solving some equations. So again, I'm just going to do 2 of these. You can check the key if you want to check the answer to the other ones, but these are similar to the one we did on the front page, which was multiple choice. So again, if we're multiplying here and distributing, just keep track of those negatives. So negative 7 times 46 is negative 42. Negative 7 multiplied by negative 2k is a positive 14k. And then on the right side, we have 6k minus 2. So we continue to solve by putting the k values on the same side. So if I subtract 6k, and maybe I'm going to add this 42 to the other side to move that one. So I get 8k on the left, and negative 2 plus 42 is a positive 40. So in this case, k is equal to 5. So we are asked to solve, and then part B says state the sets in the number system to which the solution applies. In this case, 5 would be a natural number, and then again the natural numbers belong to the whole numbers, which belong to the integers, which belong to the rational, which belongs in the real, and finally the complex. Okay, let's look at one more of these. Let's look at number 11. So we distribute in this negative, we got negative 1. Distribute in this negative, negative 3v, minus v is already there. Negative 8v, subtract 33 on the right. On the left, it looks like we have 2 like terms. So this is really like negative 1 minus 4v when we combine those. Negative 8v, not plus, minus 33. And we continue to solve by moving the v terms to the same side. So let's add 8v here. And let's add the 1 over to this side. So we've got negative 4 plus 8v is 4v. Negative 33 plus 1 is negative 32. We're going to divide by 4 on both sides, and v comes out to equal negative 8. Now it's a negative value, so again, these ones start in the integers, who belong to the rational, belongs to the real, and finally, again, the complex. Okay. That's it for video 1, and we'll continue to work through this on video 2.